Hey, good morning, everyone. It's Drew Allen. I'm the CEO of Grace Technologies and really excited to have everyone join us this morning for this kind of different webinar. We're doing a 5-year retrospective on kind of our IoT journey. It's going to be not our traditional type of webinar. We're hoping to kind of give you guys a little bit of a look behind the veil of product development and just share our journey. We think that innovation is super important in our industrial automation space, and hopefully you can learn through some of our trials, tribulations, failures, and successes. Today, join us, we have Andy Zimmerman, my partner, also Grace's CTO. And I want to just kind of get into a little bit of his background, because really the journey for Grace starts partly with him. And the digitization of what we are trying to do and accomplish is really his efforts bringing that to life. And so welcome, Andy, and it's been a journey.
Yeah, absolutely. I think, though, before we get into kind of my story, first of all, Nick named this the 5-year retrospective, and our very first slide talks about a background that begins in 2010. So 5 years ago in 2010, maybe give everybody just a little bit of a background of where Grace was, right, prior to the IoT kind of movement that we kind of began together in the 2017, 2018 timeline.
Right. So Grace really started off as with the Grace port. And the Grace port is at the heart a mechanical device that just takes connections from inside the cabinet to the outside of the cabinet. So you don't have to open up the cabinet in order to program, access the PLC, drive connections, and other kind of connections inside the device. Helps keeps workers safe. And we really created this mass customization model, which was really unique, especially through distribution. But at the heart, our core competency at that point was really more of a mechanical design competency and just understanding the application space. The next product that kind of came along was our permanent electrical safety devices. And, so we went from a mechanical device to an analog device. And, that was a big change in understanding, because we had to really understand power systems, 3-phase power, what's the difference between a delta and a Y system. And really then we started to understand arc flash and all those types of issues. And so that kind of set us up into, hey, what's the next area that we need to expand into? Where do we need to develop competency? Where do we think that there's market size and opportunity? Through a conversation with one of our distributors out in Michigan, Mac and Mac, I'm just always curious about who's developing what and what kind of new technologies. And so I was talking with Tim Mulcahy, and I said, hey, Tim, so what do you have seen that's new? And he goes, hey, we're doing something really cool at Chrysler.
Yeah.
So I think that sets you up.
Yeah, perfect. And I'll go back a little bit, back to that 2010 timeline as well, to talk about kind of where I was as Grace was kind of growing towards this point where predictive maintenance became a product line that was of interest to them. I was going through a PhD program at the University of Michigan. We were doing a lot of kind of interesting work at the time, building low-cost, low-power wireless sensors for monitoring usually civil infrastructure. So bridges, buildings, ships, wind turbines, that sort of thing. We were deploying these little vibration-based sensors across those assets to try to get early indication of failures in those structural systems. And I started a company back in right around 2009, 2010 called Civionics. We licensed some of that technology out of the university and began looking for kind of a commercial home for it. So I spent that kind of next 5-6 years growing that technology in the commercial space, seeing it deployed in a variety of different areas, and eventually ended up working with McNaught and McKay out there in Michigan to deliver some of these devices to a stamping facility there, a Chrysler stamping facility, and that led us into the conversation that we had with Grace.
I think that actually that story, getting into Chrysler and working with Mac and Mac, I actually think that there's a lot of gold in there. So let's dig in a little bit deeper. So can you talk about, you spun out from University of Michigan, you were doing a bunch of more research type projects that were funded by NSF and other government agencies. So walk through that to all of a sudden I'm working on in a stamping facility.
Yeah, it's a little bit of a convoluted story, but we came at it from the research perspective. So I was able to raise kind of the early rounds of money for Sibionics through research and development grants, largely funded by federal agencies like the Department of Defense, National Science Foundation. We did some work with the Office of Naval Research, and really all of that R&D was targeted around building a system, right, that could be deployed on any number of engineered assets to detect early stage failure in those systems and then alert the appropriate stakeholder when things went wrong. So we've been working on one very exciting grant, I thought, with the Department of Homeland Security, where we were trying to build sensors that could monitor the stability of buildings as they were either burning or after a terrorist attack or kind of a fire type event, earthquake, that sort of thing. And that project, just because of kind of the way the government worked, ended up losing funding. And that kind of made me pivot the company away from kind of that R&D focus towards finding a commercially fertile area for the technology that we'd been developing. There's a program out there in Detroit called Changing Gears, I think, that was targeted at pulling folks out of the automotive industry that were kind of previously had entry-level positions in that industry, and it was targeted at pulling them out and being able to give them exposure to the entrepreneurial ecosystem that was happening in kind of Southeast Michigan at the time. And through that program, we had kind of an exposure to this stamping plant in downtown Detroit. And in discussions with the plant manager there, it became obvious that this technology that we'd been developing for the structural applications could also be applied to monitor high-valued equipment in the industrial environment. Right, so they had some issues with these incredibly large gears that were used as part of the stamping process. Every time one failed, it was costing millions of dollars to the plant as they had to go out and procure these incredibly expensive replacements. And they were looking for solutions that could come in and help give them early indication of those problems. So we were able to streamline that technology for that application. Our initial foray in there actually targeted and not vibration, but we were looking at current and temperature values that gave them kind of an early return on investment. It was just a simple thing, but it allowed them to avoid going around the facility and taking temperature readings once per month. They could instead do it kind of every 5 minutes, every 10 minutes, however frequently we were doing it at the time. And that allowed them to save a significant amount of money just by putting these wireless sensing technologies into place.
That's like an early example, but also these examples still exist today where there's just like some very easy low-hanging fruit. Before we kind of get into where we're at today, what were some limitations, like from a development perspective, what were some limitations of the technology kind of back in those early days, and like what were you really fighting with, and what's changed kind of to now?
Yeah, it's a good question. So, there were a couple of main drawbacks when we roll back the clock to 2010, 5 years ago in 2010. The first and foremost,
you are good at math, I think.
Yeah, that's right. That's what they pay me to do. Sensing. Let's start there. Our ability in 2010 to miniaturize sensors was just becoming kind of commonplace. So a lot of the sensing technologies that were required to deploy in large numbers at low costs were just kind of becoming readily available to the masses. We also had a recent improvement in wireless kind of transmission technology. So some of these protocols that are now ubiquitous, things like Bluetooth, we use 802.15.4, which is Zigbee sometimes is what we talk about. Wi-Fi wasn't that established at that time. Those wireless communication technologies were just becoming available to the point where it was easy to pull them off the shelf and integrate them with technologies. And then I think the big thing that really drove it was the cloud ecosystem became available. So all of the big tech players started to emerge with their cloud solutions. Amazon with AWS, Microsoft with Azure. Google had their cloud coming out. So the time was right in that kind of period to start talking about enterprise level deployments of technologies inside the industrial facility that didn't necessarily have to tie into some legacy computing system. We could leverage those low cost cloud capabilities to give a customer a low cost way to start playing around with this sort of predictive maintenance technology.
That's awesome. So kind of going past just the temperature monitoring at Chrysler, what was the next phase of the project? And then, kind of talk through the rest of the evolution.
Yeah, so as I'm sure many of the listeners here today know, one of the big things that comes up anytime you're trying to monitor the integrity or the health of industrial assets is vibration monitoring. And that was really front and center from the beginning of that engagement with Chrysler. When I came into Grace, Drew and I actually did a kind of a road tour of a bunch of our distributors, and we're just talking with customers at that time, looking at where does this technology fit best, where can we make the biggest impact for our customers, and through that we really found that we had a couple of main things we needed to focus on to provide a 10x improvement in what they had access to. So the first thing there was vibration, and we've got several webinars you can look at if you really want to get into that. So I'm not going to touch.
Actually, we have one of our most viewed webinars is one of the vibration webinars, and it's really a masterclass on if you're not fully kind of up on how vibration works on monitoring of defects, and there's a very specifically defined set of rules and physics to actually kind of let you know what's happening on a process depending on what the system is. If Nick wants to go ahead and drop that into one of the chat links at some point, he's shaking his head at me because I'm doing something on the fly. But you can go ahead, and it is on YouTube, and I'll try to get it into the chat link. Hey, one other thing while I'm talking about the chat. If you have any questions, I am monitoring the chat. I have my computer up on me, and so in front of me. I'll be looking through those as well.
So I'll send that link to you guys all out after the webinar in the email. I don't want you guys to all go watch that and leave this webinar right now.
Yeah.
Sorry, shiny object. Yeah. Yes, shiny object problem.
All videos will be available on demand,
yes,
so you can get at them later. But let me pull on that thread with vibration just a little bit. I mean, it is any rotational piece of equipment, right? That's in your plant, your motors, your pumps, your compressors. Vibration is a fundamental technology for being able to give early indication of problems in those assets, right? So, a lot of our customers wait until they hear something going wrong, right? That something's actually making a noise that a human can hear. That means that probably that asset at that point is also hot to the touch. Because there's frictional kind of problems occurring that's causing that noise. And, we're probably also seeing an increased current draw at that point. So we use temperature and current a lot of times to pull information out. Well, the idea behind vibration is that we can leverage vibration way earlier in the process to say, hey, something's going on with this asset, and we think it's going to become a problem, right? So that was the big thing that we got in those kind of early discussions with our distribution channel, with our customers, was that, look, they needed a targeted solution for vibration monitoring, and I think that was the kind of rallying cry that we had right after kind of Sibionics came into Grace, which was in 2018. We kind of skipped over that part, I guess, but that was a kind of a marriage meant to happen. I think Grace was looking for a technology partner that could bring them into this digital transformation age, this era of predictive maintenance, and as a small business owner, I was looking for some stability in that industrial space to help with the sales and the marketing efforts, and so it made a lot of sense. So the first real product we targeted there.
Well, I guess I'll give some from my perspective. Yeah. So after I got introduced. We started working on trying to figure out a way to kind of partner together even before we started discussing acquisition. And it became kind of apparent that, I think we were going to be a lot stronger together. And so Andy flew out to come and meet with us, and it was really, we were very like pleasantly surprised. Where I think sometimes PhDs have a little bit of a different a stereotype potentially, and maybe an ivory tower stereotype. But what was so impressive about Andy was his ability to actually create product. And I want to double click on that for a minute. Creating product in the industrial space, especially when it's digitally enabled, is incredibly difficult. Okay, there's a ton of people who can take already created products and be able to integrate them to create to create a system that works. But to really like get voice of customer, develop what the packaging needs to look like, develop what the underlying I/O structures need to be, what the entire architecture really needs to be. This is not like a trivial endeavor, and then you start to add in all the complexities of the industrial environment, all the different types of applications, the environmental conditions. Oh, this is going to be in Canada in the middle of winter, or this is going to be in Texas in the middle of summer. You start to roll through this, incredibly complex kind of product requirements document, and really creating a product in the industrial space is really challenging. And we definitely learned some things along that way. I think when we uncovered the fact that we wanted to really hit at vibration, we also had the project going on with our panel mount nodes and that modularity. And we were trying to do a lot of things kind of at the same time, and it really led to, a very hard development process.
Yeah.
And looking back on that, it's trying to think through, hey, how could we have maybe streamlined it better? And probably we would have stripped down code sets to a little bit more of a defined use thing instead of trying to cover as many applications at once.
Yeah, it's been an interesting space because of that. Like every time we talk to anyone, a customer or distributor, there's always a new application that could benefit from a slightly modified version of the technology that we have, right? And I think as innovators, as just an entrepreneurial company, we want to deliver that solution all the time. And I think we learned early on that like we can't deliver all the solutions, right? So we've that was one of the big lessons I think that came out of those first couple of years was just we got to be good at what we're doing, and not get distracted by trying to be everything to everyone.
Yeah, the other piece I think, going back in the acquisition discussion too, was we did something unique in the acquisition where we actually took all of the IP that Andy had created, and we put this into a separate company called Perceive. And so occasionally on some of our marketing or what you'll see our Perceive entity. And our Perceive entity holds the IP, and Andy and I and my dad and one other gentleman are partners in that entity. And Grace Technology actually licenses the core IP from that entity. And then as we sell, we pay royalties back into the entity. But what that's allowed us to do is really create a avenue for government funding to be able to come into that entity, as well as our ability to have kind of a research and development arm that's outside of the typical Grace ecostructure. And so that's been a pretty innovative way. And we'll get into some of the grant work probably in a little bit. But we've been able to get $1.5 million or something in grants by kind of setting up the structure in that way, which has really led to some really incredible innovation. But before we kind of get into that, I guess let's talk about, okay, so early on, 5 years ago, 2010, to now 2018. So what are some other things that kind of changed, you would say in the kind of last few years to make IoT really explode?
Yeah. So I mean, we've seen alongside Grace, like a lot of companies starting to unveil similar product lines. I think customers are becoming more accepting of it. I'd say one of the biggest things that's enabled that explosion is in the industrial market. We've started to see some of the firewall restrictions come down. So, that has allowed for the adoption of these connected technologies that are leveraging either Wi-Fi backbones inside industrial facilities, or circumventing that entirely via some sort of cellular connection to get out to the cloud. These have certainly streamlined the ability to put these sort of technologies in front of customers. I mean, I think also the general maintenance worker, we're starting to see a younger group pop up, which that allows for kind of more I guess entry level or a younger approach to ingesting data, right? So whereas a lot of industrial systems are set up for the way they were largely 20, 30 years ago, we're starting to see a movement towards different types of technologies in that industrial space. I think one of the things that we learned early on, though, is that in order to successfully sell anything to the industrial environment that's a predictive maintenance technology, we really needed to focus on the application or the solution, right? Yeah. As opposed to trying to sell a widget that's just a one-off device that's going to provide some sort of value. We needed to provide a comprehensive solution that took into account some of these unique things that pop up in the industrial world, right? So, we took some time those first couple of years to set up an internal capability to talk with customers about those applications and be able to really not just technologically, but as a business support those installations, both going out into the facility before anything had been sold, to talk about wireless deployments, to make sure that the IT departments were set up correctly, walking through installations with them, dealing with system integration. We'll get into some of that a little bit later here, and then just really sitting with the data that we're collecting over time and making sure that kind of it provided a successful path for customers to get the value over the lifetime of the sensors that were being deployed.
Yeah, so we talk a lot. We talk a lot internally about control versus monitoring, and there really is different. Rule sets, I would say, for control versus monitoring, and this makes monitoring actually very difficult to kind of implement in an industrial facility, because the industrial facility doesn't necessarily need the monitoring for the machine to function at every minute of every day, right? And so what it becomes kind of like, oh, I forgot to have my windshield washer fluid in my car. Well, now I go through a thing of bugs and I can't get the bugs off my windshield washer. Whereas I might have kind of ignored that alarm. And so getting to kind of installing a monitoring system is a different type of approach. Also, a wireless system in an industrial facility is just inherently tricky. And we definitely learned from some failures in that wireless system deployment. And, really from our perspective, there is no way around doing an on-site kind of wireless survey in order to really understand that, hey, the offering I'm trying to put in has line of sight. There's not all sorts of weird electromagnetic interference. I mean, in industrial equipment, especially in the U.S., you got electrical signals going everywhere all the time, and drives putting off all sorts of noise. And we just don't we don't know what we're going to get into, and we're trying to make sure our deployments are as rock solid as possible. But definitely doing those doing a full kind of review of what needs to get installed, what the machinery is like, a review of kind of the physics of those machinery, what are the failure modes, doing a wireless audit. What are some other things that you found kind of to be important in setting up a IoT project for success?
Yeah, I mean, that customer engagement, I think, is the most important piece, right? So and we learned that early on, that if we don't have an engaged kind of maintenance workforce that's working with our application support team, a lot of times like the solution just doesn't take hold the way it could, right? And a lot of times it's an individual that steps up inside that kind of customer account and is really taking ownership for the maintenance of some critical asset inside an industrial facility, and they see the value that the data that we're providing can give. So that kind of, we're talking about not really replacing, but augmenting humans with sensors here. But ultimately, like, the important thing that we've kind of drawn out of that is, man, that human component of being able to to ingest and take action on data in a way that's meaningful to an industrial entity, like that's a super important part. I think that's it's an augmentation technology. It's not a replacement of a maintenance team. And that's kind of one of the interesting dichotomies of the work that we've done.
There's definitely if not just kind of not having a champion, but also if you have a maintenance team that just maybe isn't as disciplined as you need them to be, and they just start ignoring alarms. Mm-hmm. Well, all of a sudden, then our system's getting blamed for not for a failure that's occurring. But really, no, the alarms were sent out. You guys just didn't follow up on and go through and perform the maintenance procedures. And that's one of the reasons I really love our approach in the control space is that we can go ahead and provide those cloud-based alarms and alerts, but we can also go ahead and do it through the control system local to the HMI, to the operator who's on the machinery. And so, just where they're already kind of working instead of having to get into an email or something. I always believe in the power of the and. It's never an or approach. But definitely we've found some success in getting that information to control offering.
Yeah, I mean, and I think that was one of the impactful early lessons learned, honestly, was the industrial space. Some folks want all that data in the cloud, just like your standard Internet of Things technologies provide. Right. But we did find a lot of feedback that, man, it'd be great if we could get this information in the PLC or the PLC and the cloud, or I want it in my SCADA, or, I want it into my existing CMMS system. Like all of these were pieces of feedback that came back that really led us down the path of developing out seamless, easy to use technologies for taking the data that we were capturing and making it available in the right place at the right time, right? So, we sell a lot through the Rockwell Automation distribution channel, and a lot of our folks here in North America are using Rockwell systems, from a PLC perspective. So, we went through the process of developing out the add-on profile, which I think has played dividends in the Rockwell ecosystem. We've got similar easy tools to use, kind of for integrating our devices with other types of technologies, and that's been a big, I think, value add to customers and to integrators, whoever's touching the interface between the sensor data and the person who's receiving that information. We try to make that pathway as seamless, as easy, as diverse as we can make it. So that's been an important thing. Anything else we want to pull on that topic, Drew?
I think that really thinking it, having a culture of reliability in that facility, so understanding and understanding where your downtime is coming from, mm-hmm. understanding your cost of downtime really allows, when you're selecting kind of an IoT vendor, really allows you then to understand where you want to put your resources first and what you need to pay attention to. Look, I think it's most easy to typically go ahead and roll out a LTE based offering first. Mm-hmm. Okay. So get a trial, trying to get, we sell our kind of startup kits, mm-hmm. Which is typically like one gateway and 5 sensors, and they're able to kind of go ahead and try this on different machinery, move things around, understand it. The gateway just plugs into into a typical outlet, and you can go ahead and collect data for a while, see if it's collecting data the way that you want. Get your feet wet with the technology in the easiest, quickest way to deploy. But then being able to roll out an entire solution, I think, takes a lot more architecture. Yeah. And really understanding that, for instance, one of the integrations that we have is with Fix on a CMMS system. So if you're using a CMMS system, having that IoT data in a centralized system that doesn't need to be referenced somewhere else mm-hmm. is really critical. Understanding that applications for control and I/O, saying, okay, hey, I want to have a beacon on my machinery so that when the vibration is over XYZ, I'm starting to flash a red strobe light. I mean, I think that there's a lot of discussions here. And by the way, we're talking about vibration, but it also could be current monitoring. We have a hotspot monitor in our offering as well. So for switchgear, which you want to talk about a criticality assessment. Almost everyone gets this one wrong, right? And so they're super concerned about all the motors down at the facility level. They just forget that like it's also super important to monitor like the big switchgear that's feeding all of the motors.
If you don't have electricity, your motors aren't doing much.
Right? You're not so concerned about your bearings if you don't have any power to those. And so I do think that that's a really super important thing, is to understand those criticality assessments. Try to get your feet wet, do some startups, do some data collection, and get your team engaged and working as part of that problem. So
we've kind of, maybe we come back to that. We've been talking about these industrial integrations. I think the other piece of this puzzle that I think some of our customers have taken to is they've already got some customized piece of software that they want to be able to provide data through, right? So in addition to the kind of industrial integrations using Ethernet IP or Modbus TCP IP, also making our cloud-based information available via just a standard public API. I mean, that's when we talk about the last 15 years, maybe, the migration of cloud-based technology towards a place where we can expose basically everything in our system to a third party over API, so they can build their own interfaces. That's been kind of an important aspect. We're not going to be everything to everyone, right? But being able to provide our capabilities in ways that it can be ingested elsewhere, I think, is an important piece of that puzzle.
I think that there's always going to be kind of new technologies. I mean, definitely a cloud-to-cloud integration over an API seems to be the most kind of beneficial. We're also working on some MQTT integrations as well. Ethernet IP in the control world is kind of our premier integration with the Rockwell add-on profile. But we also have Modbus TCP IP as well as Modbus RTU, and kind of everything has its place. There's just depending on what kind of environment you're running.
For sure. So, anything else you want to touch on here on this guy? Do we want to jump?
Let's see. So I talked a little bit about it, but to talk about the digital transformation, let's talk about the fact that up until kind of Andy's, up until Andy coming in house, we did not, like I said, we didn't really run software. And so learning how to develop software is an entirely different undertaking than designing a mechanical device, right. Okay? And then let's say you're designing a mechanical device, and then you're also designing software, and then you have a digitally enabled product. It's actually kind of like the worst of both worlds, because it's actually the most complex, because then you're talking an entire full stack where you've got purpose-built firmware, you've got PCB design, you're choosing what type of chips you want to be able to use, what kind of wireless protocols, and this whole thing needs to work seamlessly from both the mechanical package all the way through upwards, to the stack. I can't stress how difficult it was to come in, especially as a non-technical CEO. Sometimes I play engineer at work, but I'm not a developer or a coder. Though with the new ChatGPT interfaces, I can become a little bit of a cyborg.
You're an expert.
I stayed at Holiday Inn Express last night. But product is really hard. And if I was going to give some advice to anyone, people are going to be your most important asset in that space, and oftentimes you're not going to get it right on the first go. And so fortunately, I had a partner who knew this world, but we definitely struggled through getting the right talent in-house, being able to understand exactly how to run a development project with that complexity, how to be able to run a test bed to make sure that we're testing through all the configuration settings, understanding how to test wireless reliability. I mean, all of these things are capabilities that did not exist at Grace. I think now we've been able to really develop a more robust ecosystem because of all those learnings. And I anticipate that at Grace, we won't just have an IoT product line. I think all of our products are going to have a digitally enabled component. Yeah. And I think that's not just the future for Grace, but I think that's the future for the rest of the industry. I mean, I think hey, even fuses are going to have some digital communication interface at some point, and probably some already do, right? But there's going to be a constant. Transducers are going to be everywhere. Embedded computing is going to be everywhere. And I think that this is par for the course. And so start developing those chops and start developing your people now in order to, prepare you for the future.
Yeah. So Drew jumped the gun a little bit. We're going to talk about some of our future things in 1 minute, but let's just hone in on kind of what we did over the last few years.
I do have a couple questions here.
Oh, good.
So there was a question from Brandon regarding kind of perceiving Grace Sense feeding each other. Yes, they do. We're sister companies, and Perceive is able to get in some grant work that allows us to kind of come in and feed Grace with some new innovative technology. Brett Lincoln is asking about our thoughts on IO-Link and integration into IO-Link capable devices. Andy, thoughts on IO-Link?
Yeah, so we've circled the IO-Link wagon quite a bit over the last couple of years as it's become a protocol that people are using. I mean, I think in our case, the big thing that has kind of kept us away from having a native IO-Link interface is that typical IO-Link applications are control focused. So they're delivering data at a very high rate reliably, right? And that's, in our case, a lot of times
and power intensively.
Yeah, it requires a lot of power, right? So we've got battery powered wireless nodes that are really doing a vibration assessment. If we're talking about our vibration technologies, once an hour. And those data trends don't really need to be. They don't require a 10 millisecond refresh rate. So there's actually some technical reasons why we haven't. It's just like IO-Link doesn't support the quantity of data that we send on as infrequent a basis as we send it. So there's kind of it hasn't been the best protocol for us to engage with. Now that said, I'm pretty sure you can get an Ethernet IP to IO-Link kind of converter situation up and running, or any one of our other situations. But yeah, we don't have a direct IO-Link offering.
Yeah, and from I'm good friends with Reed Shook, and he's got a company in the space called Cortigo, and they're doing some really interesting stuff on wireless IO-Link. Hey, it's a big world out there. If you guys haven't checked them out, go and check out Cortigo. It's been a good kind of a good thing, and maybe at some point we'll be able to find the right application that needs that level of reliability and control mechanisms. But at this point we haven't been able to quite the matrix hasn't quite worked out yet.
Yeah, I think that's a good way to put it. Blame the matrix. Yeah, perfect. So this actually feeds us into this quick topic I just wanted to make sure we discussed. One of the things that we really spent kind of that post-COVID era building out was we saw a lot of folks offering vibration technologies that were very data centric, right? I'm going to collect a bunch of data and using either AI techniques, machine learning or whatnot, or just data-centric approaches to anomaly detection. We're going to provide information surrounding defects. When we kind of polled our customer base, we found that a lot of folks wanted to be able to ingest data in a very similar way that they had from vibration analysts over the years, right? So you typically have a vibration analyst come into your facility. They're going around once a month, once a quarter, and they're providing a detailed report at each asset that they're going around and monitoring on their routes, right? And so we spent quite a bit of time building out an interface that mimicked what a vibration analyst would do, and we try to provide data in a very similar way to those vibration analysts. So it allows us at that level to build on kind of ISO standard vibration levels to give indications to our customer base that something's going on. Now, in the background, as Drew said, we've been doing a lot of data-driven work, but we did find that this interface that allowed for I think an easier level of understanding to folks who are used to seeing that kind of report paid dividends within the company.
And the UI really, it actually looks like the piece of machinery that you're monitoring. And so understanding, hey, okay, here's a compressor. We're putting a node here, and here. There's 4 nodes on this piece of machinery that's doing the monitoring. and then the interplay between these and allows us to kind of do a set of rules and more of a physics-based approach.
Yeah. So that heuristic-based kind of ecosystem was really designed around our thought that whatever type of technology we bring to bear in this IoT world, this predictive maintenance world, needs to be trustworthy, right? And one of these grants that Drew's talking about that we brought in through Perceive has really focused on that trustworthy piece by providing explainable artificial intelligence, and that's something that's kind of a future concept. I'm probably jumping ahead now. Yeah, that's actually the last bullet. So I'll hold that for the next couple of minutes.
Let's talk about trustworthiness just for a minute and why that's important.
Okay. Yeah.
I was talking with one of our customers, and they said, basically, if you get it wrong 3 times, everyone's going to ignore it. And so we think that nuisance alarming is a significant problem in the IoT space. There's also, though, this issue of I'm just not trusting the system, and so we want to make sure that we're alarming at the right times, and we're not over alarming, and we're also not under alarming. Right? There's this sweet spot. And that's been really important to try to narrow in on. And then we've been able to send out on some of our early deployments, we've been able to go ahead and we're starting to collect data, and we notice that there's problems on some of the machinery, right? And they're like, no, there's no problems on that machinery. And so they weren't really initially trusting the data. One of our partners in the space, Dan Ombre, Full Spectrum Diagnostics, we sent him out to a facility down in Florida, and he was able to kind of do an entire kind of assessment. And sure enough, what was the failure?
Some mechanical issue.
Yeah, some mechanical issue that they were completely unaware of, and they just didn't believe it was happening because the machine seemed to be running okay.
Yep.
Right, and it would be running okay for a while, and so then after that, they took our data a lot more seriously. So it is important to really build that trustworthiness with your, kind of with your customers, but and also just for any systems that you're deploying.
Yep. So that brings us to kind of what we're doing now, what we're looking to do in the future. And I think the first place to start, and this actually comes right out of that vibration discussion, is we're getting ready to kind of launch a next generation of our vibration and temperature monitoring technology. And so I'll hit on a couple of the main points, and then Drew can jump in kind of on top of that. I mean, we really when we looked at what do we need to make our legacy vibration and temperature platform 10 times better, there were a couple of main things we were focused on. Number one, Drew discussed some of the RF things. We needed a stronger RF connection, and I think we've accomplished that. With kind of an order of magnitude better RF connection between that device and our gateway products. We were looking to be able to do a couple of things that are vibration specific that our previous platform couldn't provide. So one of those is to be able to provide better shaft speed detection, right? So for those of you that have any sort of background in vibration analysis, it's super important to know how fast the shaft is spinning in order to give any sort of insight into the type of defect that you're seeing on that asset. And we previously had kind of a vibration-based kind of set of firmware that would do that analysis and provide an estimate of shaft speed off the vibration sensor. This new platform will pull from a variety of different sensing sources, including kind of an improved vibration-based approach, a magnetic field sensor, and then we've got the ability to actually draw the PLC-based shaft speed into our analysis in the unit itself. So those things will create a significantly better ability to do what we call defect classification or fault analysis. So that will kind of aid in that response.
Hey, just as a quick interruption, I'm being informed that Nick's going to be dropping a poll into the chat. So feel free to jump in and answer those. We'd love to get your guys' feedback on kind of what we're discussing. And also, I'll just mention again, we got the chat open, so feel free to drop in with any questions. We are getting into kind of the section where we'll discuss a little bit of where we think things are going and some of the new offerings coming out in the space. I would invite anyone who is going to be kind of in the West Coast area to come and visit us at Automation Fair.
Yep.
We'll be showing off all the latest and greatest things there in the third week of November. Correct, Nick? Yes.
Yeah.
So feel free to come and visit us at the Grace booth at Automation Fair. But anyways, let's talk a little bit about I remember sitting down with you though.
Yeah.
and we were like, okay, hey, we got to define what our next generation of this vibration temperature node, And so I got up and I went to my whiteboard and I go, we just need to 10x everything, And
yeah, no problem.
yeah, I literally have a screen. It's still up on my board, and and I think we actually really accomplished that. I mean, whether it was RF range, we wanted to reduce the complexity of the code set down by about 90%. I think we were able to get to probably about I think Isabel told me 75%. We were able to increase battery life. We were able to increase kind of also the transducers we were using. I mean, what were some other kind of key learnings on the VBTX project?
Yeah, I mean, the big kind of things we found with the legacy platform, we didn't design it for hazardous locations, right? Mm-hmm. So that was one of the big things we went through on this last product design, was to make sure that it could be deployed in Class 1 Div 1 areas. Which also came kind of associated with that was just making sure that our temperature range was a little bigger. We found now battery powered technology is tough to use anytime it's super cold. So we'll get to the batteryless solution in a second, but being able to make sure that just the wide range of applications that we've seen our legacy nodes deployed in, both temperature wise, in washdown areas, all of that sort of thing. We wanted to make sure there were no kind of environmental reasons that would block the use of the technology going into the facility. So I mean, maybe the next thing is to talk about the kind of batteryless approach.
Yeah. So we also we acquired a company back last year called Perpetua, and Perpetua takes a thermal differential coming off of typically either a steam pipe, a motor, or other types of kind of warm assets in a facility. We need a 20 to 30 degrees C temperature differential, and it produces power, enough to power our wireless nodes. But today, it's really purpose-built for the Emerson Rosemont wireless line. Yep. And so we partner with Rosemont on that line, and you can go ahead and order those offerings through Emerson. It's about a puck this big with some kind of spike sticking out of it, and so we really think that one of our next development projects will be integrating all of the hardware that we took for the VBTX and connecting it into one of our Perpetua nodes, or Perpetua offerings, and so we believe in the future of kind of a batteryless IIoT future, and we think it is possible and not something actually that's that far-fetched.
Yeah, it will tackle several applications directly, in addition to just getting rid of the hassle of having to change batteries, which I think is nobody likes that, right? But we can get at higher sampling rates. So typically whenever any customer or any company is selling an IoT line, ours included, that's battery powered. We talk about battery lives when we do an analysis once every 10 minutes or 15 minutes or once every hour, right? But there are some vibration applications where, having it on continuously would be a really great thing, right? And that's something that, if there is a thermal gradient in the area that's significant, we can potentially power these like always on kind of applications using that thermal gradient. So that's one thing we're excited about, is being able to kind of provide another non-tethered option for those always-on types of applications. I think also I mentioned, you want to deploy somewhere really cold. Well, actually, really cold is a really great place for the thermal energy harvesting, because you got a motor that's hot, you got an environment that's cold. Man, I mean, we can do vibration analysis there, very easily using that temperature gradient that exists.
So we're really excited about that. I think probably be looking for a product in that space in the second half of next year. Maybe we'll, if you have some interesting applications, we'll probably be looking for alpha and beta sites coming up soon. There's another kind of interesting technology too that we don't have developed in-house, but I'm going to go ahead and mention a friend, Dennis Carissis with Volta Energy. I think it's doing some really, really incredible stuff on motor current signature analysis. I know that there's other players in that space. I would say though that Dennis is one of the smartest people I know, especially on electrical power. I would really want to just give him a shout out. Check out their website. If you need help getting in contact with them, feel free to drop me an email at drewa@gracetechnologies.com or drop me a note on LinkedIn, and I can get you guys connected. They've done some really, really cool stuff in a bunch of different industries. So I really enjoy working with him on stuff.
Hey, we're like right on time. We got one more bullet, guys. So we're gonna just do a brief discussion, I think, of AI, right?
Yep.
Like that's probably, there's a lot of questions surrounding that. It's a discussion Drew and I have been having really over the last 5 years, the actual last 5 years, not the last 15 years. And I think we've discussed perceive. Like one of the big things that we have been focused on is we know that a large application in the industrial space that causes downtime more often than not is when bearings fail, right? And in that industrial ecosystem, a lot of times that bearing failure comes somewhat unexpectedly. And because the maintenance cycles aren't necessarily super frequent, you might not be able to get in and maintain. The ability to predict bearing failure is a super impactful capability for anyone in the industrial environment. And so we've kind of had a diverse approach to tackling this particular issue over the last 5 years. I've worked with some partners up at Iowa State, now at the University of Connecticut, in building out a research portfolio that's really targeted at this very specialized domain. So, number one, we built some kind of data-driven that augments our existing kind of heuristics-based approach, data-driven approaches to classifying the health of vibration assets. So that can tell you, hey, what type of bearing failure you're actually seeing. And those kind of AI-based techniques have been pretty effective. We also then have taken that kind of to the next step, which allows us to probabilistically predict when those bearing failures are going to happen. So that's saying, hey, there's a 10% chance this thing fails in the next 7 days. There's a 50% chance it's going to fail in the next 3 weeks. But man, there's a pretty high chance that you've got 6 weeks until this bearing fails, right? And these are not things that we've commercialized yet, but we've been building kind of that underlying R&D in the Perceive entity in an effort to kind of bring those alongside our existing hardware offerings that Grace has. To Drew's point earlier, we're afraid of delivering technologies that aren't trustworthy, right? Mm-hmm. And so part of that grant is to position those technologies in a way that not only give the end user the ability to trust and act on the data. That probabilistic approach is part of that, but also that can provide explainability, right? We need AI approaches in that world that are going to give the reasons why they're predicting those eventual failures. Right. Here's an example of a time a similar bearing failed, and these are the data trends that led to that failure that are very, very similar to what we're seeing right now. And so that's kind of going on in the background here at Grace, in terms of building out the kind of next generation of AI technologies.
I also believe heavily kind of in the LLMs as well, and we've been able to create a ChatGPT wrapper, I guess, to be able to coordinate some different agents in ChatGPT to help run customers through troubleshooting. Mm-hmm. So basically, hey, what's going on? Let's inspect the problem, troubleshoot the problem. Here, now let's try some things to rectify the problem. And then ultimately, once the problem is resolved, we're able to run a full root cause analysis report. That's called our Foreman XAI offering. These models just continue to get better. And, I would say that we're seeing typical responses that you would get probably out of someone with kind of 7 to 10 years of experience in the industrial kind of field, which is just absolutely crazy. I think that there'll be continued insights. It also is very beneficial for like a supercharged Control F in documentation. So I don't know how many of you guys, get a new machine that ships out and it's, 1,000 pages of documentation. Well, something just broke. Being able to really supercharge that Control F search and be able to layer in an LLM is like an incredibly useful piece there.
Yeah. I mean, to give Nick one more thing to do, we did have a webinar, a 2-part webinar last summer. That kind of discussed this AI, gave some kind of sneak peek at the time into the generative work that we did, the GPT-based kind of maintenance assistant. So feel free to kind of come back and watch those on demand.
Yeah, and hey, for anyone who's listening to, hey, we're always looking for people to collaborate with and for Stuff that, if you see a problem in your factory, we'd love to partner with you guys and try to figure it out and see if there's a product that maybe, works out at the end of it. Much to the dismay of Simon Sinek, unfortunately, we did not start with the why. And I realized that as I'm like sitting here listening, why did kind of an electrical safety company get into the reliability space? It started off at a conference that I saw, and there was a alarming statistic. 70% of all injuries in industrial facilities happen during reactive maintenance. Yeah. And there's something that happens in a facility when the important process is down and everything's broken and steam's coming out of a pipe and kind of everything's gone haywire that, makes us stressed and narrows our field of view. And maybe we don't follow the procedures we should, or we take shortcuts. And that's always when accidents happen. Yep. And Grace is super interested in keeping people safe. And we think that this maintenance offering, helps keep people safe, helps make reactive maintenance a lot less frequent by becoming proactive. In addition to that, though, there's something just incredibly gratifying about eliminating waste in factories. If we want a better and brighter future, having a bunch of broken machinery running around is not the brighter future. And we love our brothers who work in those factories, brothers and sisters who work in the industrial facilities, and we know that your day can go a whole lot better if stuff's not just broken. Yeah. So we hope to be your guys' partner in that space. And if there's any other questions, we'd love to take them. There's a question regarding, are you aware of the solution by Oldie Softing, Analyst Inside? We are aware of that solution. We think that we're able to supply data to that Oldie offering if you want to use their machine learning approach. One thing that we've always found in these more machine learning approach, I would call our approach more of a rules-based approach. Yep. Is that the machine learning approaches don't typically do that much better than the rules-based approaches and require a lot more training. So maybe, Andy, if you want to get into that.
Yeah, that's a big topic, but in general, right, specifically in the vibration case, any two failures can be very, very different, right? Even the same piece of equipment in two different facilities can produce two very different signatures. And so the machine learning approach to predicting failure is it's a hard problem, and it's one that we've kind of come at it from the perspective of trying to provide the most impactful data to the right places at the right time. So we would love to make our data available to any sort of complementary solution that could benefit from the wireless ecosystem that we've built out. Now that said, in the background, obviously we're also building our own kind of analysis tools, but our intent is not to ever hide our kind of core sensing platform behind that curtain and force folks into that kind of ecosystem.
And actually, I think that's something we didn't touch on as well. Is Andy and I's kind of approach in the space is we default to open. Yeah. And so we are one of the only cloud optional offerings in the space. And so we're more than willing to, work with other partners, make our data available to other people, allow other people to write, applications to sit on top of. We love kind of partnering with anyone in the innovation space and doing whatever makes sense for the customer and the application.
Agreed.
Are there any other questions? I know we're at time, but we'll stick on for a few more minutes. Thanks. Brandon liked our answer, so thank you. All right. Any other questions, guys? Feel free to connect with me on LinkedIn, Drew Allen. Also, Andy Zimmerman's on LinkedIn as well. And Nick will be sending out some follow-up information for you guys. And we appreciate you all taking the time and look forward to hopefully increasing reliability in the factory with you guys.
Yep. Thanks a bunch.
Thank you.